In this video, I'll be talking about electrons, protons, and neutrons inside an atom. So this is a topic for general chemistry. I'm going to talk through this video in point form. So that's all you have to remember if you're on exam. And I'm going to tell you how to answer questions, the general questions that could be asked from this section. So an atom is electrically neutral. Okay. Why is it electrically neutral? Because inside the atom, you get a nucleus. And around the nucleus, you get a cloud of electrons. The reason I say cloud of electrons is they're not going around the nucleus like in a track, like on a track, but it goes like in a spherical form. So it's like a cloud. We can measure the probability of finding an electron within that sphere, within that space. We are not going to address that in this video because this is a basic video. So atom is electrically neutral. When you say neutral, because inside the atom, you get protons, subatomic particle called protons, and neutrons. Protons we consider positively charged, and this is neutral, no charge, and electrons negatively charged. So if an atom has the same number of electrons, these negatively charged electrons, and it has the same number of protons inside the nucleus, then it is electrically neutral. That's why an atom. If it is not neutral, which means if it has more or less number of electrons than the number of protons inside the nucleus, it could be negatively charged atom. Then we call it an anion. If it is a positively charged atom, we call it a cation. Cation is, remember, that's how we draw cat's ion. So remember that like that, cation. So anion negatively, cation positive. This is determined by the number of electrons within an atom, because the number of protons and neutrons in an atom at this stage, remember, are fixed at this level. It's fixed, okay? So let us, so electron, we notice E. If we go for the charge, mass, charge, we say -1, and mass is 0. These are all relative values, relative to something. So if when you say somebody is tall or taller comparatively, that means we are taller than someone else. If we are going for absolute values, then you have to tell the actual height, 6 foot, 5 foot. So here we are telling -1 as the charge of electron, because relative to proton, which is +1, and neutron, which is neutral. but actual measurements of charge is done by the unit called Coulomb. So there are charges which we don't address directly, but it's okay to remember if you want to. But these charges would be given if you are in physics or chemistry, if you're doing calculations. That is the charge of a proton, because you can see it is positive. I don't put the value there, a sign there, but it is proton, it's positive. So the electron would be negative. C means Coulomb. That's the charge. That's the unit for the charge, Coulomb. So neutron, right? So when I say -1, actual charge is this, but you call it -1 because relative to proton, it's same charge, -1, +1. When it comes to mass, so mass, actual mass is given kilograms, but in this case, I'll give you in grams. So the mass of a proton is 1.67 to, we say, 10 to the power -20 grams. So neutron also, same, we can say it has the same charge, okay? But when it comes to electron, the mass is 9.109, but 10 to the -31. See, -30 and -24. Therefore, relative to that, we say electron has 0 mass, proton has 1, 1. So when I say this 1, 1, they are relative charge, relative mass. Electron -1, no mass. Proton +1 charge, mass 1. Neutron, no charge, 0, mass 1. That's the important to remember. Okay, let us go to the next step. So in an atom, inside an atom, you have in the nucleus protons and neutrons. When you add these two together, the number of protons and number of, you call it the mass. Write it clearly here. Okay. Call it mass. The number of protons give the atomic number. Okay. So the number of protons or number of neutrons inside the nucleus tells us the atomic mass. That's what gives the mass of an atom. Now, if you just take the number of protons, that is the atomic number, which tells the position in the periodic table. Okay, so you should keep a good periodic table that gives all the information, as many information as possible, and you can write the other information you need in the period on the periodic table, so that you have that information with you whenever you need it. That's one place. Okay. So let me just write down. So in the periodic table, you will see the first one is hydrogen, and it is group 1, or they might say 1A. And then same level, you get helium here, and it is either group 8A or they put 18. So it depends on the periodic table. Okay. So then below that, I'm not going to write the entire periodic table, but you get lithium, and it is the number 3. So the first position hydrogen, second position helium, third is lithium. But lithium comes under group 1 and 1A. Helium comes under 8A or 18. Now, I will do a separate video about the periodic table and what information you can derive from the periodic table. But here, just to show you what it means to say positions in the periodic table. So if hydrogen is the first one, because you count the position from left to right and go down, hydrogen 1, helium 2, lithium 3, beryllium 4. Then you have a space here, which is for the d orbitals. and then you start here with boron, carbon, nitrogen, oxygen, fluorine, then neon. Okay. So if I take carbon, 1, so let me mark it, 1, 2, 3, 4, 5, 6. That means carbon is in the 6th position. What does it mean? It means there should be 6 protons. So carbon, we can say, has 6 protons. Okay. Now carbon, because carbon is an atom, it is neutral. That means it has 6 electrons. So positive 6 cancel out with negative 6. The electric charge would be 0. So electrically neutral. Then when it comes to the neutron, well, we have to see the mass because we have to know the atomic mass here, right? So if I tell carbon atomic mass is 12, then we know there should be, we know already 6 protons. Then neutron should be 12 minus 6 to get 6 neutrons. That's how we do the calculation. So when you write these things, there is a system which we explain. So let us say I'm writing about carbon. Instead of telling that it has 6 protons, I put 6 here. This tells us the number of protons or the position. P means protons, okay? Don't take it as the position. And then if I put 12 here, that is the atomic mass or mass number. It's a better word because it's round figures we are putting there. Okay, atomic mass would have some decimals. So, but that is the mass number or the atomic mass is 6. So 12, always take the higher value out of the 2, which is on the top, as the total of protons plus neutrons. The bottom one as protons. So if you are given a question to ask you what position, you look for the number of protons. If they give you the position, you know the number of protons should be the same. If you're given the mass, then you can find the number of neutrons by deducting the number of protons from the total mass number. Okay. Now, for an atom, it is easier. Then if they ask for an atom number of electrons, it's going to be the same number as protons. Because I stick to telling that atomic number is number of protons, because protons gives us the position. But number of electrons could change. It could have more electrons or less electrons if the atom is not an atom, which means not electrically neutral, but it has a charge and it becomes an anion or a cation. Anion being negatively charged, cation being positively charged. Now, let me do another example to show that one. So you know that if it is a neutral atom, take this example. It's easy. 6 is protons, which is same as electrons. 12 minus 6, you get 6, which is neutrons. That's it. Now, suppose you are given 7, I'm writing something here, 3, and plus. Now, whenever you see a sign here, whether it's negative or positive, you know it is an ion. Because it's positive, you know it is cation. Then what you do, if they ask what is the proton number, this doesn't change. It's always 3 protons. And it is also say, proton, it means the position in the periodic table. This is the 3rd element. Now, 7, we know it is the mass number or the atomic mass. I'll call it that mass. So that means protons plus neutrons. So we know protons 3. So 7 minus 3, we get 4. That's the number of neutrons. Okay. What about electrons? If this lithium was an atom, this is how we solve this one. Okay. If this was an atom, you would have only 3 electrons, correct? Because it's only 3 electrons, because 3 protons cancel by 3 electrons. But now it has a positive charge. That means it has lost, because see the case here, 3 plus 3 minus originally in the lithium atom. Now to have a positive, extra positive charge, 3 plus, if it was 2 minus only, I get lithium plus ion, which is a cation. Therefore, the easy way to remember it is, if you have a positive charge, you take away that number of charges from 3. So I had lithium plus one value, 1 plus, therefore 3 minus 1, I get 2. That is the number of electrons. So whenever there's a positive charge, you take away that number of positive charges from this number of protons in the original atom. If it is a negative charge, what happens? So if I have 35 Cl minus and 17, you know this is protons. This is proton plus neutrons. Therefore, 35 minus 17, you get the number of neutrons. Okay, so that is 18. Now, if they ask what is the number of electrons, it is given by this 17. Earlier I said if it was positive, you take away. If it is negative, you add 1, because that means there are more electrons than, in this case, 1 electron more than the number of protons. So you add 1, then you get 18. That's how we solve. So that's all you have to remember in this. 2 numbers, the higher one is the atomic number, or the mass, atomic mass number. And the low one is the protons. It tells the position. The difference between the higher one and the low one gives the number of neutrons. For the electrons, if the given element doesn't have a charge, you say it has the same number of electrons. If it has a charge, if it is a positive one, you take away the number of positive charges from the protons, number of protons. If it is a negative charge, you add that number of negative charges to the number of protons. That's it. Okay. Then they might give you some of the cases where there are the same element the same element will have different mass numbers. Okay, so if I take now, if I take oxygen 8, means it should be in the 8th position. But I have put 18 and 16. Is it possible? Yes, because 16 tells us the neutron plus protons, and this tells the neutron plus protons, which means for this oxygen, there are 8 neutrons, 8 protons, so the total is 16. But when it comes to that, we know 8 protons, but how many neutrons? We take away from 8 from the 18, so I have 10. Okay. 10 neutrons. It is the same number of protons, but different neutrons. That is called isotopes. So in the periodic table, they hold the same position because the number of protons is the same, but it would have different number of neutrons. Therefore, they are called isotopes. Okay, like if it has different number of electrons, then it becomes a charged one. It could be called anions or cations. But when it has different number of neutrons, then the mass changes. So then we call it isotopes, and I will cover that part in separate video, especially how to calculate the abundance. Okay, so we will do few questions to understand what it is. So if we take hydrogen, let us say we do the first atomic number, then I'll put atomic mass here just to make you understand why atomic mass is not exact round figure, because it has isotopes there, so the percentages vary. So atomic mass, which is actual mass, has decimals, but if you take the mass number, which is the neutrons plus protons, we get that figure there. So if it is hydrogen is the first position, atomic number is that. Atomic mass, if you check in the periodic table, you get something like 1.01. But the mass here is, if you put 1, and then number of protons would be 1, number of neutrons would be 0, number of electrons would be 1. You should understand this one is. Suppose I tell you if H has plus 1, then atomic number is still 1. The mass would still be same, because mass is contributed by not by the number of electrons, but by the number of neutrons and protons. So the mass would be 1, because it's a calculation. So proton would be 1. Neutrons were not there at the beginning, So it will be still 0 because we are talking about the same hydrogen, which is actually protium. The name is protium if hydrogen just has only one proton. Then electrons would be, what happens? You take, because it's positive, you take that number out from the proton, right? So you get 0, which means no electrons. Okay, similarly that. So we did carbon 12. Okay, we'll do it position atomic number is 6. 6. Atomic mass is roughly, if I'm looking at the periodic table, I can see, yes. Yeah, I'll put 12.1. So the mass is the higher number, 12. Proton, 6. Neutron, the difference between 12 and 6. So I put 6 here. And because there is no charge in this carbon, electrons will be 6. Okay, so let us take another one. Potassium and 9. Now, by now, you should know, the moment you look at it, you know the 19th position, so atomic number. Okay, so you can look at the periodic table and see the mass of potassium. I have 339.1. So this is 19. So the mass is 39, the higher one. Number of protons, 19, the bottom one. The number of neutrons has to be the difference between the two. So I put 20, the difference between 39 and 19. And electrons would be 19 because it's neutral, right? Potassium, there's no charge here right now. Let's do one more. Let's take magnesium. Okay. Now when it's magnesium, you can see 12. So atomic number should be 12. Number of protons should be 12. Go like that. It's positive. Okay. The actual mass of magnesium, I'm looking at the periodic, is 24.31. So the difference between 24 and 12 would give the so difference between the magnesium 24 and 12, we would get the neutron, which is 12. Sorry. Then the mass is given 24, the higher number here. What happened to electrons? Number of electrons. Original atom would have 12 to match the number of protons. So you take away when it is positive here. So if I take away this 2 here from this 12, I get 10. Alright, if you perfect this one, then you can answer any questions to do with finding the atomic number, atomic mass, which is the easiest one of the beginning of chemistry to understand chemistry.